Hi everyone, welcome back. The learning goal for this video is for you to be able to use the periodic table to identify the group and the period of an element. To be able to identify the element as a metal, a non-metal, or a metalloid. The periodic table organizes 118 elements into groups and with similar properties and places them in order of increasing atomic mass. Once again, you'll be utilizing the ACS periodic table, so I'll keep referring to that in this unit here. And you should have a printed copy of the periodic table with you as you're doing your homework and studying for assessments. In the periodic table, elements are arranged according to properties. So groups contain elements with similar properties in vertical columns. So groups are the elements that are in vertical column. Periods are horizontal rows of elements counted from top to bottom of the table as periods 1 through 7. So you can see on this periodic table here, group are in vertical columns and periods are the horizontal rows. So this is period 1, 2, 3, 4, and so on and so forth. Let's look at the ACS. Now the group numbers have been updated. So instead of seeing, for example, group 1A, group 2A, 3B, so on and so forth, it has now been accepted to just do 1 through 18. So this is group 1, 2, 3, 4, so on and so forth until you get to 18. And this periodic table actually has that labeled for you to remind you it's the vertical columns are the groups and they will have similar properties. And then the periods are the rows. So once again, group numbers are written at the top of each vertical column. Historically, the letter A was used for what was called representative elements. You're not required to label 1A through 8A, but if you are using the textbook, they will show the older periodic table, and the A elements were referred to as the representative elements, also known as the main group elements. But for right now, like currently as it stands with the ACS, we just do 1 through 18. The letter B in the historical way of numbering groups, B represent the transition elements, groups 3B through 12B. And the alternative new naming numbering system uses numbers 1 through 18 across. Both systems still are currently in use. They're both shown on the periodic table of the textbook and are included in the discussions of elements and group numbers. But I did just want to highlight that the ACS, American Chemical Society's periodic table, doesn't have them on there. But it won't be needed because you will see that this is color coded for you in terms of how to identify the different groups on the periodic table. Once again, as a reminder, groups are vertical, periods are the horizontal. The representative elements are anything from group numbers 1, 2, and then 13 through 18. What's in the middle are the transition elements. The group 1 elements are the alkali metals, and they include lithium, sodium, potassium, rubidium, and cesium. And you can see that on the periodic table here. These are group 1 elements, alkali metals, excluding hydrogen. We'll discuss more about the unique nature of hydrogen later on. Alkaline earth metals are group 2 elements, and they are shiny but not as reactive as group 1 metals, and they include beryllium, magnesium, calcium, strontium, barium, and radium. Strontium is responsible for giving the red color in fireworks. It's group 2. Group 17 elements are called the halogens, and they include fluorine, chlorine, bromine, and iodine. Chlorine is a gas, bromine is a liquid, and iodine is a solid. And you can see them on your periodic table, 17 elements. Now you may notice we didn't include the last 2. Anything in parentheses is not long-lived. It's going to decompose. It's more radioactive in that sense. And so we do not include that, but the elements we would find in nature are the ones not in parentheses, but they are stable and we can study. So let's do a study check, pause the video, try this on your own with access to your ACS periodic table, and then come back and check your work with me. All right, so group 17, period 4. So we're gonna use our periodic table like a treasure map here. So looking for group 17, and then I'll have to zoom out here, period 4. What did you find? Bromine, good. So that was A, bromine. What about group 2, period 3? I didn't get that. Group 2, period 3. So period 3, group 2, that would be magnesium. Excellent. And what about group 15, period 2? 15, period 2, that intersects at nitrogen. Good. So we have A, C, C. All right. So we can also classify elements as metals, nonmetals, or metalloids. And metals take up the majority of the periodic table. They're located to the left. And in this case, there's a zigzag line here indicating that anything located to the right are nonmetals, but anything along the heavy zigzag line are called metalloids, and they will have properties in between metals and nonmetals. On your periodic table, the metalloids are in gray. Anything to the right are nonmetals, and anything to the left are metals, except for hydrogen, which will be treated like a nonmetal. Metals, except for hydrogen, located on the left of the periodic table, are shiny and ductile. So ductile means they can be pulled into wires, and they are great conductors of heat and electricity. Metals are solids except for the exception of mercury, which is a liquid. Nonmetals located on the right side of the periodic table are dull, they're brittle, and they're poor conductors, but often good insulators. They have low densities and melting points. Metalloids, which are located along the heavy zigzag line or in the gray color on the ACS periodic table, exhibit properties of metals and nonmetals. They're better conductors than nonmetals, but not as good as metals. They are used as semiconductors and insulators because they can be modified to function as conductors or insulators. And you see that silicon is one of them, which we know is a good semiconductor. So here are some characteristics of metals, metalloids, and nonmetals. And the reason why we're doing all this work with the periodic table and classifying all these elements is because it helps us to understand the properties of those elements. So for example, and then silver would be classified as a metal. So immediately I would know that since it's a metal, it is shiny, it's ductile, it's malleable, which means it can be hammered into sheets. I know that since silver is a metal, it's a good conductor of heat and electricity. It's used in jewelry, tableware, and it has a high density and a high melting point. Sulfur, because it's On the right side of the periodic table is a non-metal. So immediately, without even seeing sulfur, I know some of its properties. It's dull and it's brittle and it shatters when it's hammered. It's like the opposite of the metal. Therefore, it's also a poor conductor of heat and electricity, but then that makes it a good insulator. And some other properties, sulfur is used in gunpowder, rubber, and fungicides, and it has a lower density and melting point compared to metals. And the metalloids are just somewhere in between. They can be shiny, they can also be brittle, they can shatter when they're hammered. They're a poor conductor of heat and electricity, somewhere in between the two. And in this case, antimony is used to harden lead, color glass, and plastics. And it has an intermediate density and melting point compared to a metal and a non-metal. So go ahead, pause the video, try this study check on your own with the ACS periodic table, and then check your work with me when you're done. All right, let's identify each of the following elements as a metal, a non-metal, or a metalloid. So what did you identify sodium to be? Good, that's a metal. So if we look at the periodic table, we see sodium, it's an alkali metal, it's to the left of the gray element, so we're good, that's a metal. What about chlorine? Good, that's a non-metal. It's to the right of the gray ladder there, so that is a non-metal. Silicon, that is a metalloid. It's one of the gray elements on the ACS periodic table. What about iron? Good, that's a metal. And carbon, non-metal. So once again, let's look at iron. That's to the left of the gray ladder, so it's a metal. It's even listed as a transition metal. And then carbon is to the right of the gray ladder. It's a non-metal. But also remember, halogens and noble gases are considered non-metals as well. And in this class, we will not work with the lanthanide or actinide series, so you don't have to worry about those elements. All right, pause the video again, try the study check on your own, and then come back and check your work with me. So it states list all of the elements that match the description. So, well, looks like I already have the elements here. All right, my mistake, but let's review over it then. So if we have metals in group 14, let's check, actually, no, let's check actually, because we're looking at only metals in group 14. So this is kind of like a puzzle hunt. So we've listed the elements here, but I need my periodic table just to make sure. So if I'm going to group 14 and I'm listing the elements, definitely not carbon, not silicon or germanium here. But it looks like I have tin and lead. So let's look back at the list. And definitely tin and lead, but yeah, definitely not carbon because that's a non-metal. Silicon and germanium are considered metalloids there. So, all right, cool. Non-metals in group 15. So I'm looking for non-metals in group 15. So let's go back to our periodic table. Let's find group 15. We're looking for non-metals. Looks like that's nitrogen and phosphorus. Those are the non-metals because these are metalloids, and that would be considered a metal. So let's go ahead and highlight nitrogen and phosphorus as the nonmetals in group 15. And then finally, metalloids, somewhere in the between, in group 14. So metalloids in group 14 are silicon and germanium. Those are the gray elements there. Those are the metalloids. And so we would highlight silicon and germanium there. All right, so let's link this to our health. Of all the elements, 20 are essential for the well-being and survival of the human body. 4 of those elements, oxygen, carbon, hydrogen, and nitrogen, make up 96% of our body mass. And most of the hydrogen and oxygen is found as water, which makes up to 50 to 60% of our body mass. Macro minerals are calcium, phosphorus, potassium, chlorine, sulfur, sodium, and magnesium. And they are representative elements involved in the formation of bones and teeth. They are useful in the maintenance of the heart and blood vessels, muscle contraction, nerve impulses, and acid-base balance of body fluids. And they're also useful in the regulation of cellular metabolism. So here is a figure of a periodic table highlighting the major elements in the human body, the macro minerals that we just listed as well as the micro minerals, trace elements that are also needed for us to function. All right, thank you for watching. And as always, email me with any questions.